Certainly. Let's give that a shot then. Yeah, so that's obviously just going to be like basically a full exam. Well, worse than an exam actually, because it'll cover basically everything. I wonder how much bigger this is. The Tech Free 31, the Tech Active 24, Extended. Yeah, okay, the Extended's got so much stuff in
46
it.
extended responses. Holy.
Yeah, doesn't mess around. Yeah, any preference on where to start?
No, just I guess top to bottom.
Cool. All right, we're going to start out with stuff that you've been practicing a fair bit. But would you rather skip some of the probability stuff or sort of?
Those questions were actually that's 18A.
Oh, that is 18. Yeah,
Yeah,
okay.
I
I
was
was
about to
going to
say I just
say
did the
that
questions.
did feel a bit weird to start off at probability. Yeah, okay. There we go. 19. There we go. That's better.
Um,
Um, yeah, all right. Let's crush it. We got f of x, g of x. What is f of g of x? That should be fairly trivial.
9x squared plus 6x plus 7.
Yep, nice and easy. Just shoving g into f. Awesome.
Infinitely many. So that's just need to make it the same thing. Okay.
Yes, correct.
I remember doing this thing at school as well. Uh,
Mm.
I had to jog my memory back again.
Okay. Well, the fact that it's simultaneous linear is an important factor.
Yeah, like that means like the polynomial, so like say if it's 3y, right? And since they're both equal to 0 as well,
Hmm.
so that doesn't that mean that k plus 2 like has to be equal to 3?
Does it mean exactly that? It would look like that. Yeah. Um, yeah. Yeah, I think that should mean that.
But then okay, so if you get k plus 2 is equal to 3, that means k is equal to -1. But then if
Yeah,
k
then
is
that's
equal
not
to
going to
negative
work for
1,
the
that's not going to work.
kx. Yeah, okay. Hmm. Yeah, it's harder to understand there. Um, one of the ways I like to think about this is graphically, which is for infinite solutions. Yes, the equations have to be identical, but also what that means graphically speaking is that the equations completely overlap.
Yeah.
So if you think about the criteria that it would be for two linear lines to fully overlap, there's two main criteria you're looking for there.
Yeah, you need the c to be the same, and you need the gradient to be the same.
Yeah, correct. And so that's the approach I typically use for this because as you see, it can be easy to fall into that thing and be like, oh yeah, the coefficient on that y is 3, therefore k plus 2 should be 3. It just doesn't tend to pan out.
Yeah, I'm gonna just try something real quick.
Mhm.
He's a real constant. Constant means like it has to be like a whole number, right?
Yeah,
No,
well, a number.
no, I don't know. I'm gonna get this one right. I got some like -1 plus minus root
Well,
13.
that does end up coming right, yeah. So I do mean like a constant just means it had to be a number,
Oh, okay,
which yeah, an irrational number is
so
still
it's
a
okay.
number. Yeah, yeah, that was good.
Cool.
Would have been a quadratic formula. Looks a bit weird. You usually don't get plus minus roots in these sorts of things. You do oftentimes get quadratics to solve for it, even though it is linear, oddly enough. But yeah, that does end up panning out right. Was that like a? Did you convert to y because mx plus c and then match m's or?
Yeah, so first I put both the equation into y is equal to mx because there was no c,
Yeah, yeah,
and then yeah, just um yeah,
yeah. Equate m's.
yeah.
Yeah, that's chill. That's the way I usually would do it. There's other things you can do, like with matrices and determinants. I've got a idea of that in the notes, but we don't do matrices and methods anymore, so it's a bit redundant.
Well, say like in an exam, right? Would if you like use like a matrices to like solve this type of thing, if it doesn't like specifically ask you to solve using a type of like technique, is that inadmissible or like do they accept it?
No, it's totally fine.
Oh, okay,
In fact, like this book was printed for this study design, and in their solutions, they actually have a matrix solution for it.
okay,
So it's totally fine. You're allowed to use matrices as you see fit. It's just not taught, so not required.
right. Oh, this is not gonna be good, eh? Um,
Transformations.
describe a sequence of transformations that maps the graph of y is equal to 1x onto its image. Okay, dilation, reflection, translation. Okay. Um, flip in the horizontal axis,
Yep,
then dilate 3 from x and 2 from y.
that was good. Yeah, and decent order too. Reflection first. Actually, reflections and
Oh,
dilations you can do
it's
in.
it's interchangeable, isn't it?
Yeah,
Dilation, reflections, just translation needs to come afterwards.
yeah, correct. Because reflections and dilations are basically both multiplications, so you can do those in any order. Yeah, okay. Oh, that's good. Sweet. And that was also really good as well because you're able to just sort of spot what this is. And did you do the x dash y dash stuff, or did you just kind of see
No,
what
I
it
just
was?
looked at that. Just looked at that.
Nice. So much for it being bad. You can skip some steps with shortcuts. Very nice. Four doesn't look so bad.
Chain rules.
Indeed.
Okay. 21 x to the power of 6
Mm-hmm.
times like in brackets
Yep.
5x squared minus 3 to the
5x
power of
squared.
6
Yep. Yep. Okay.
times 5x squared minus 1.
That was good. Yes. Okay. Solid. F dash 0.
Just two?
Say again, sorry.
Two.
Oh yeah, just two. Yeah, easy. That's right. More diff, more f dash, and then again for 6. We'll do as many of these as you want to do, I guess. They're all quite similar.
Two x. Natural log two x
Yeah,
plus x.
x natural log of x plus x. Yes, that's it. Nice and easy. Product rule.
I should roll. Okay. First, it's numerator times diff of denominator. I think. Because
V.
the numerator is
I
v,
think
right?
it's so denominator is v.
Oh, okay.
It's a vu dash minus uv dash. I
Over
think.
v squared. Yeah.
Yeah.
All right, cool. Okay, 2x plus 1 times cos x. So x cos x. Okay. Um, this might be wrong, but is it cos x minus 2 sine x over 2x plus 1?
This minus 2 sine x on 2x plus 1. Missing a. Oh, okay. Um, the 2x plus 1 on top, did you try to do some sort of cancellation?
Yes, I don't know the right there.
2x plus 1 only goes on the cos, not on the sine.
Yeah, yeah, that makes sense for sure. Yeah.
Yeah, okay. So you're going to have a 2x plus 1 on the cos and then a squared on the
Yeah,
bottom.
yeah, that's what I had originally. Then I try to be smart ass.
Okay. Well, I mean, you can sort of do it by splitting the subtraction, but you're still going to have a
No, but
2x plus 1
yeah,
squared.
it has to be on both terms for me to cancel.
Yeah, correct. But as in what I'm saying is you can split the fraction and then one of them has the
Yeah,
cancellation and the other doesn't.
yeah, yeah, but that's just kind of
Yeah,
counterintuitive, I
it's
guess.
not necessary. In fact, like for this, because you're only solving, you're not actually asked to figure out f dash. You're asked to figure out f dash pi over 2. So
All right.
whatever simplification you do is actually up to you, how far you
Yeah.
want to take that. At least as far as the f dash. As soon as you're comfortable subbing in the pi over 2, then just go for it.
Right. Okay. Cos pi on 2. Okay. 0 times. That doesn't really matter then. Minus 2 sine x pi on 2. Minus 2 over. pi plus 1 squared.
Yep, that was it. Minus
Yeah.
2 over pi plus 1 all squared. Nice. Yeah, that's that one. There's two more of these if you want to do them.
Could you just go over like chain rule when it's in the power?
Chain rule when it's in the power.
Like
So
you see
whether it's
how
power or not is irrelevant. You always just want to know what's the basic version of the function I'm looking at. And this would be just like e to the x. Yeah. Um, so essentially you'd say your f of x is e to the x, and so you now have f of sine 2x. So basically this is the thing that's your u
cool.
for chain rule.
Okay, so that f of x remains the same, and then you just multiply with 2 cos 2x. So
But yes, just multiply by 2 cos 2x. So yeah, 2 cos 2x e to the sine 2x.
yeah.
Yeah, that's the one. Yeah, and that actually was a double chain rule as well, because you got the chain rule of the e up into sine, but you also got the sine 2x. Very nice.
Can we move on to the next one?
Yeah, certainly. General solution of sine minus cos.
Pi 2x minus cos 2x is equal to 0. That only happens when x is pi over 8, I think.
Pi over 8, so pi over 4, yeah. So that's one of the solutions to it.
And then there'll be another one as well.
There'll be infinite, actually. But yeah, I
I
get what
mean,
you
like
mean. Within one revolution.
base. So is it going to be pi on 8 plus pi n?
Pi plus pi n. Close. It's going to be close to that. A bit of a challenge that's come with the shortcut of just sort of doing it by observation is you miss a little bit about what that 2 does beyond just halving the pi over 4. Oh, sorry, but beyond just doubling your pi over 4. Pi over 8, rather, into pi over 4. This impacts another term in the general solution as well, that being
Period,
the n
right?
pi. Well, period, yeah. And that furthers down into also impacting the n pi that's part of it. So if you were to do it probably a bit more uh, as intended, you would do the sine equals cos, divide them both into tan, and then you'd have your tan is equal to whatever, 2x is equal to pi over 4 plus pi n, and then divide everything by 2. So you still get your pi over 8, but the pi n also gets divided by 2. So, you can do these shortcuts, like spotting this immediately. Just beware that you've still got to factor this into the n pi, or 2 pi n, depending on if you're sine, cos, or tan. Make any sense? Or
Yeah, if I brought cos 2x to the other side, right?
yeah,
Would I divide that with sine?
yeah. So you divide both sides by cos because sine
Oh,
divided by
yeah,
cos gets you
my
tan.
bad.
Yeah.
Right, then you get tan x is equal to 1.
Yes.
Tan, yeah. Okay, right.
And then yeah, you would go from there. At least it's to show that math. You can absolutely do the shortcut you mentioned, but just be aware that the division at the end for
Yes,
the n pi. Are
all right.
you going to continue from there, or do you want to move on to the next question?
Um, Move on to the next question.
Easy. Big circular function, amplitude and period first up, and then sketching the thing. Let me see, how bad is the sketch going to be? It's only negative
I
pi over
remember
pi.
you showing me that technique where you put just like a placeholder in the brackets, which helps with sketching and stuff.
Yeah, yeah, yeah.
This is like a prime example where it helps. I guess with smaller ones, it's like you can sort of figure it out, but
Yeah, this is a bit nuts. You don't
Yeah,
usually get a coefficient or a translation in the exam anyway. But yeah, um, it'll certainly help here.
yeah. Okay. Anyways, the amp is gonna be 4
Yep.
period. Okay, 2x, and then so it's just pi.
Yes, just pi. Correct.
Yeah. All right. So it's the graph of the function, and it's from negative pi to pi. Okay. Cool.
It'll be a bit of a time consumer. Um, if you're comfortable enough with your ability to do it tech free, I'm happy if you want to cheat out a few things tech active to speed things along, but up to you.
Oh, I think I'll just do it tech free.
Yeah,
Yeah.
totally.
Okay, so solutions are going to be negative 13 pi on 24.
A
Sorry,
bit off. We're going a bit off now. Um,
I had got negative 13 pi on 24, negative pi on 24, 11 pi on 24, and 23 pi on 24.
yeah, those are a bit out of whack there. Like for instance, the furthest right should be 5 pi over 6. Um, how far off is that? Double 20.
Oh, wait, no, I see what I've done. Oh, hold up, hold
Oh
up.
yeah.
Yeah, no worries. Let me just fix it up real quick.
Okay.
Okay. Negative 2 pi on 3,
That's better.
negative pi on 6, pi on 3, and 5 pi on 6.
Yeah, those are all good. That's x. Did you get a y-intercept?
Minus it. Oh, I'll figure it out.
Yep.
When x is 0. Is it 2 root 3 on 2? No, wait, that doesn't make
Just
sense.
just two root three.
Just 2 root 3, sorry, yeah.
Yep.
2 root 3.
That's good. So that's x, that's y. One thing's left to do.
Turning points?
Quite.
Or
Turning points,
endpoints?
endpoints. Yeah.
Yeah.
Yeah, turning
Um,
points, for whatever reason, they're not too fussed about. I guess because there's a lot of them.
yeah,
But yeah.
fair enough. Okay. Um, negative pi 2 root 3 and pi 2 root 3.
There you go. Yeah. Fun fact about symmetrical domains. The endpoints are always going to be the y-intercept. It doesn't
Uh,
actually matter what sort of horizontal translation or vertical translation you do, simply because of how, if you shift it forward or backward, that y-intercept is going to shift along with it as well.
Is that only with sine though? I'm guessing.
Only with sine. See, that's
I think it would be valid with cos, right?
I don't
Actually,
know, because sine and cos are just shifted horizontally from
yeah,
each other, pi over
it could
two.
be valid with cos.
Because yeah, I'm kind of just looking at this picture and I'm thinking, okay, if I were to shift it left or right in any given direction, um, where the endpoints are with respect to negative pi and the y-intercept are also going to go down and up at the exact same rate. So shifting horizontally seems fine. Shifting vertically should never be an issue. Everything would just go up and down, whatever. Sine and cos shouldn't matter because those are already just horizontally changed from each other. So I'm going to take a stab and say that it's actually always the case that your endpoints, as long as you've got a symmetrical domain, are going to be the same as the y-intercept. I always knew it was common for that to be the case. I'm pretty
Yeah.
sure it's always. I'd have to double check to make sure, but that's just sort of my analysis of it. But yeah, I'm assuming if you got all those key features right, drawing the graph wouldn't have been that hard, considering
Yeah.
there's only one way to do it at that point. Okay, cool. That's that. Hyperbola.
So it'll be a long time since we did one of these.
Well, you said similar about the transformations, then you smashed it, so let's see if you can do the same with the hyperbola.
Um, okay, so y-intercept 0, 3,
0, 3, yep,
x-intercept 6, 0,
yep,
and vertical asymptote at x is equal to 2,
that's good.
and horizontal asymptote at y is equal to 1.
That's also good. Yeah. Really only one way to draw that. You've got, I'm assuming, top left, bottom right quadrants.
Yeah,
Yeah.
I mean, yeah, yeah.
Okay, and there is actually one thing that's a bit unique here.
Endpoint.
Yeah.
I didn't really ask about endpoint, but we'll give it anyways.
Yeah,
Um,
so I guess it's implied the fact that there is a domain there.
yeah, 1 minus negative 4 and 3. Oh, is it 7 on 3?
7 on 3. Yep.
Yeah, negative 1, 7 on 3. And
Yeah.
then
Yep.
infinity, yeah, just speaks for itself.
Yeah, that one, you don't draw anything. It's already contained by the asymptote. We got an exponential, and we're doing inverse related stuff.
Okay, y is equal to natural log, bracket x plus 3 on 5, bracket close, and then plus 1.
That's good. Yep.
Find the domain of the inverse function.
As like a minor nitpick, it does say find f inverse, so you'd probably want to write f inverse instead of y, but otherwise, yeah,
Yeah,
that's
my
just a
bad.
very minor nitpick.
Find the domain of the inverse function. Okay, so that's gonna be the range of the original.
Yes,
And that exponent has a range from negative 3 to infinity.
sure does.
So that's going to be the domain for f inverse.
Absolutely. Yeah, well done. Solve circular function from negative pi over 2 to pi over 2.
Cos 5x on 2 is equal to 1 on 2. Okay. Um, Okay, negative 2 pi and 15 and 2 pi over 15.
That's good. Yeah, nice and symmetrical.
Okay,
Okay. These are kind of fun. These will show up every now and then in a tech free, or even a tech active multi sort of thing.
what the heck? Wait, hold on. G of x is equal to 5x squared. G of u plus v plus g of u minus v. What? Two. Oh, okay. All right, let's see. 5 times u plus v squared. Oh, I think I know what this is hinting at. It's like something to do with the quadratic expansions.
Yeah, I would say expanding out what you just got would be a good idea.
Yeah. Oh, sorry. I just yeah got kicked.
Oh, you got kicked out. Yeah, okay.
Um. Okay, so my left side, right, is 10u squared plus 10v squared.
Yep.
But if it was to prove the right side, then it would have to be 10u squared plus 5v squared.
5a squared. No, the 2 is a bracket on everything.
Oh, yeah. Okay. Yeah, then it's okay.
Yeah,
Yeah.
yeah,
That's
that's
really
good.
good.
Cool. So that means you would have did the left hand side, expand that all the way out, did the right hand side, expand that all the way out, and see that did the same thing.
Yeah.
Yeah. Okay. Cool. Um, yeah, that's pretty much it. What they did instead, ever so slightly, was they did this expanding out sort of thing, but then they refactored what they had back into this, and then just said, "Ah, I have 5u squared here, I have 5v squared here, therefore, win."
Yeah.
Rather than, yeah, all the way out. It's the same thing though.
Average value.
Yeah. Average value exponential from 0 to 4.
Um, I don't know how to do that, but I think I might know like um actually no, I probably don't know how to do that. Because is it like you look at the first endpoint, then you input the second endpoint, and then you like divide by two or something?
So that's what we typically do in data, right? Where you have all your data points, and then you just say, "Yep, add all the data points up, and then divide by number of data points." Um, Typically, when you're doing
Oh,
that
this is
in
the
methods,
diff, right?
it's anti-diff specifically, but yeah,
Oh, yeah.
it's in that calculus region. Yeah. So there's a very specific, like, average value means a very specific thing in methods, and it is the average value equation. Do you want to see if you can spot it in your bound reference somewhere, or do you want me to just pull it up?
Is it the average rate of change thing? Oh no,
Not the average rate of
that's the
change. That's for slopes. Average value is the integral version.
no. I don't have that.
Don't have it? That's fine. I'll pull it up. Let me quickly find that. Calculus, apps of integration. I think I put it in apps. Yeah, it's just this thing. So you're doing similar, but with integration, what you can think of integration as is kind of like what we're doing with the average value when we're adding up all the data points and then dividing by number. It's sort of the same thing here, where integration is taking slices of area, summing all that up, and then you're dividing by the length of the domain, or in other words, just the number of slices, basically.
Yeah,
It's very conceptually the same thing. In fact, if you ever work with electronics for whatever reason, um, integration in that domain is actually a repeated summation if you ever do that sort of thing. Like even coding related stuff, integrators in code are repeated sums.
right.
Got that equation down?
Yeah. Is the answer e to the power of 4 minus 1 on 4?
E to the 4 minus 1 on 4. The 1 on 4 should be on both of those terms.
Oh, sorry. Yeah.
Yeah,
E to the power on 4. E to the power of 4 on 4. I got
yeah.
my numbers jumbled up there.
Ah,
Yes.
okay.
E to the power of 4 minus 1 all over 4.
Yeah, that's better. Cool. All right, that's that. Eric Cubic. Bless you. You got intercepts, turning point. Oh, you got heaps of information.
The graph of y is equal to x to the power of 3 plus bx plus c has intercepts 0, 6, and negative 2, 0, and has a turning point where x is equal to 1. Find the value of c. X is equal to negative 1. Find the value of c.
Hmm.
Right. C is 6.
C is 6. Yeah, it's a bit of a freebie. The plus C is pretty much always the y-intercept for a polynomial type thing.
Yeah. Write down two simultaneous equations in NP. I wanted to say we're gonna just use the two intercepts, but I don't know if that's right because if I use the first intercept, I'm just gonna get y is in I mean 6 is equal to c.
Yeah.
Uh,
Hmm.
One of them is gonna be, let's see, 0 is equal to negative 2a to the power of 3. I mean sorry,
Negative.
no, my bad, Negative 8a.
Yeah.
minus 2b plus c,
Yep.
and turning point. Is there a way to know the y value just by having x? Because
To get the actual y value. Probably going to be tough because you got an a and a b in there.
yeah,
You get y in terms of a and b, and that's
okay.
that's good enough. I will say it's probably a bit longer approach. You'll find pretty quickly in your approach getting there, there'll be a simpler way to do it.
All right. It looks like to me that it's going to be -1 and 3.
Negative
Oh,
one and
it won't be. Shit. I don't know. So -1 is the midpoint between 0 and -2.
that's a bit. So that works with quadratics.
It
When
doesn't
it
work here.
comes to like two x-intercepts, cubics tend to be lopsided. Um, sorry, what am I saying? I mean, yes, it is. It is in the midpoint. You're right. Um, uh, in terms of like y value, yeah, I don't know what I was trying to say there. I just think in the lopsidedness. It is the midpoint. I don't know if that's super helpful to know though.
Yeah, I'm not too sure with this one.
Okay, well, follow your idea before of getting the y value, the turning point. How would you go about doing that? Even if it is
Um,
in terms of a and b.
you'd put you'd solve in x is the equation.
Yeah.
That would just give you -a, -b plus c.
Mm. Yeah. Okay.
So yeah, it doesn't give you much.
Mm. Okay.
And then we have a
What do we know about turning points?
diff is 0.
Yeah. There you go. So keyword turning point is pretty much your brain should be circuited in such a way where as soon
No,
as you
I
yeah.
was thinking about that, but how are you going to use diff here? Like, if you have
Well, how do you diff polynomial?
3ax squared plus
Mm-hmm.
b,
Plus b. Yeah. That's pretty convenient. We've cut out c even though we already knew it. But you got the diff equation. You've got the x for which you have a turning point, and like you said, diff is 0. So you've got your y quote in quotes value um, from that, and then yeah, that'll be the second equation for which you can do simultaneous off of.
yeah, okay. Um,
So pretty much any time you see turning point, it's like the vast majority of times you're going to do
so
something
my
with
second
diff.
equation is going to be b minus 3a is equal to 0.
B minus 3a, yes. Oh, uh, wait, b minus 3a is equal to 0?
Oh, no, b plus 3a.
Yeah, there we go.
Hence find two values of a and b. So A is equal to 3 on 7.
That's gone a bit off.
Oh, okay.
Should just be 3. Yeah, I was wondering why that was taken a bit. Let me just double check. So you got 3a plus b equals 0 as one equation,
Yeah.
and you got 4a plus b equals 3 as the other.
Oh no, I didn't have that.
Okay.
All right. I had -8 minus 2b equal to -6, but I think I can see you can just make
Oh, it
that.
is. Okay.
Yeah, wait, hold on. 4a. It should have been 4a minus b is equal to 3.
4a. This one's saying plus b. Hang on. 4a plus b equals 3.
Oh no, yeah, that makes sense.
Oh, yeah. Yeah.
3. But how come if I use this, it's still the same equation. How come if I use that, it's like it doesn't come up? Maybe I just did something wrong.
I mean, it's probably just going to be some algebra error mistake. If they're the same equation.
Yeah. Let me just rectify that real quick. Yes, A is equal to 3, and then
Yeah,
if A is equal to 3, then B is equal to -9.
that's it. Yeah, nice. Yeah, it's those. Again, inverses with exponentials, rule and domain, as we've done before. And then this is a fun one, g of g inverse.
B. Okay.
Um, we'll run out of time on this one. So what I
Oh, that's
do
okay.
want to do is actually just highlight this, because this is the fun bit. Um, you almost don't need to know any of this to at least get the look of the graph of this one.
What
Um,
would that look like?
well, that's a good question. Um, do you recognize anything about the fact that it's a composition function with its own inverse? There's a special property of this.
Is it something to do with like domains and ranges?
Yeah, so you'll still need to follow the rules of composite functions when it comes to domains and ranges. More so domain, because then you just extrapolate from there. Um, so f of f inverse of x is always equal to one thing, and that's x. So whenever you have a composite function where it's in composition with its inverse, the rule is
Oh,
always
right,
x.
because they reflect over the line y is equal to x. Yeah, that makes
Yeah,
sense.
it's got to do with that, and
Oh,
the
so
fact
then
that the y of one is being fed into the x of the other. So when all is said and done, you get a straight line, y equal to x.
so that's a bit
So
of a yeah trick question.
yeah, I mean, you still need to care about this domain bit in here,
Yeah,
and
yeah.
the rule. Well, this is for inverse, so I guess you just sort of do that. But for this, yes, you know the rule is always going to be x. It's more so what's the domain of this one going to be. How would you go about getting the domain for this one?
Is the outer is the domain?
So outer, you always go from x goes into the inner, and then that goes into the outer. So the x is coming from the inner.
Okay,
So you've got your, if I draw this out, got your x value, and that gets fed into g, oh, yeah, g inverse, and then whatever comes out of g inverse becomes the x value of g. So domain is right there.
okay.
Yeah, cool.
Thank
All
you.
right, first
Good
class
to
of the
know.
new year.
Yeah,
Welcome back. We
yeah,
got
it
up to
feels good.
question 15. Do as many of these as you want. Obviously, we're gonna have a class tomorrow if you're there for that, which you usually are.
Yeah.
And yeah, we're just gonna be doing as much of this until the group starts filling out more.
Yeah, I'm gonna have a chat to some of my friends. I don't know why. Every time, I used to like over the last year, I used to ask like some of my friends like if they wanted to join,
Hmm.
and they always used to like look at the price and like, oh, then they start getting cold feet. But
Yeah.
I feel like
Um,
this is
depending on when you asked,
it
it
because
had
you changed it to 70 once.
yeah, it
Yeah,
was at 1.70. Now I've dropped it down back to 40 for the new year,
right.
which is a lot more accessible.
Yeah,
Um, But yeah, so if you told them around that time when it was 70, feel free to let them know again. It's gone back down.
right.
Um, but yeah, either way, I'll continue to fill it out anyway. So we'll
Yeah.
see how we go.
See ya. Thank
No
you.
worries. Take care.